Yeah, so it's the
Do they have like slides for it?
yeah, I think I don't know whether the book has adjusted a lot. I saw the slides, but it's like
Oh
um
yeah.
yeah,
So
it's just like
it's changed.
yeah, it's like it was not for this chapter, maybe I thought. Or the guys
Oh,
they made it so condensed that I was like, oh, there's no point in adjusting this because then I'll have to change everything. So
awesome. Nice. Okay.
yeah, so but basically I think what it's stressing here, it's like we're gonna learn about some interesting things to deal with, especially how to work with like dates. Yeah, so it's like how to work with dates, like how to create dates and sort of date times from strings, also from individual components and from like other components. It mentioned something like that. And then it says like to warm up, think about how many days there are in a year and how many hours there are in a day. You probably remember that, you know, most years have 365 days, but leap years have 366. Do you know the full rule for determining if a year is a leap year? The number of hours in a day, like if you have the daylight savings. I don't know whether you guys usually have that.
Yeah, I don't. I think I don't have it.
Yeah, the daylight savings, you know, when like you see how the book club get disrupted, you know,
Yeah.
like you'll be missing like almost 2 weeks to deal with this daylight saving stuff.
Yes.
Yeah. So we said like we'll begin by showing you how to create dates from various inputs. And then once you got the data, once you got a date time, you can extract components like year, month, and day. We'll then dive into the tricky topics of working with time spans, which come in a variety of flavors depending on what you are trying to do. Then conclude with a brief discussion of the additional challenges posed by time zones. So the prerequisites is like a lot of this chapter will be based on this lubricate package, which makes it easier to work with dates and time. So it's already included in tidyverse, so we don't have to do much. Then it starts with like creating date and time. Like when we are creating dates and times, there are three types of dates and times that refer to an instant in time. Like a date is like it prints the date, whilst a time within a day, it's a tuple that prints as time. And then a combination of the two is a date plus a time. It uniquely identifies an instant in time, typically the nearest to the nearest second. It also prints like a tuple, like a date time. Yeah. So he's saying that we are going to focus more on the dates and times. And like you should always use the simplest possible dates, possible date times that work for your needs. So he starts giving some examples of the today and the now function, which is I believe from the lubricate package. Like if we just use this function, it gives us the sort of the date.
Today's, yeah, today's date.
Yeah, it gives us today's dates. And now it gives us the date and the time and also the time zone. So it seems like the default is the UTC, the Universal Coordinated Time, something like this. That's the default time zone that R uses, it seems like. So otherwise, the following sections describe the 4 ways we are likely to create a date or a time. So we could directly load the data, like it could be, we could use the read R function to load the data directly. In that way, we could like sort of load a CSV file as we could read it in R as a CSV file, and then, or from a string, we could also get our date or time from a string, from an individual date time component, or from an existing date or time object. So now it tries to give an example of if, sort of importing. During importation, if your CSV contains like the ISO 8601 date or time, you don't need to do anything. Read R will automatically recognize it. So the ISO, I think it's this format, where it's like in the year, the month, and the day format, like any format like this. And then I think the time, it assumes that it's UTC. So if your like CSV file is in this format, once you load it in R, you call it, it immediately comes out as a tuple like this. Like you have the date and then the date time. Yeah.
Interesting.
Yeah. So it's like the read CSV does it automatically for us. It just recognizes it. But that is if it's in the ISO like this format. And so that it's an international, this ISO stuff is an international standard. And I think it's interesting because even if you look at this product certification, I don't know whether you have some any experience working with those stuff. You have a different ISO certifications for like products if you want to import or export or something like this. So it's a pretty interesting stuff.
Nice.
Yeah. So it gives an example. For example, in ISO 8601, May 3rd, 2022 is like this. So if we put in this, I will automatically recognize what we are trying to say. So it's like it brings it takes the format of the year, the month, and then the date. And then the hours take the format of the hour, the minute, and the second, which are separated by this like the column. So we could also, if we need to use other time formats, then we could just adjust to using this functions. The call time is like, is it the column type, something like this? The date type, the column date, or so we could use these functions to do some adjustments in the default timing. And these are just the different formats that work with read R. So we could see the codes. The code with the percentage sign of it gives us the year in 4 digits. When it is small, it gives us the 2 digits. The M gives us the number of months. Yeah, the day, it gives us like two digits date. Like this one gives us 1 or 2. So that's the time zone, the capital Z time zone, either the America or the Chicago time zone, and the small z like offset from the UTC. Like I think the default is UTC. So if we want to use a different time zones, we have to specify with this Z or the small Z. Yeah, so I think this is just some codes we'll be using along in the chapter. So this is an example. This seems to be a bit like it says, and this code shows a few options applied to a very ambiguous date. So like from this, how do you get this date? Just from looking at this?
This is like an example, right?
Yeah, it's like but it's a bit ambiguous. So it's like it's just trying to give an example of how we'll use these functions it has mentioned here. Like
Yeah.
this call, the call type, the call date, and the call date types. How we can use it.
Yeah,
Here.
he will just construct our format, the date by hand. Like the call date here, it's using the code that they provided before, and then they format a string with the same like structure of the input in the CSV variable here. So you see that like the month, then the day, then the year, and y is small, then that's why it's abbreviated like with just two numbers.
Yeah.
So yeah, this is just using the call date to format or to match the formatting of the input of the CSV date.
Yeah. So why I'm saying it's a bit interesting, because look, it's basically, from the codes here, a small y should have just given us like 2 digits. But
Yeah,
it's
he
given us 4 digits.
yeah, I think he understand it when you format it with the code, then transfer it in R to the R time date or time. I think the date type in R, yeah, like this.
Yeah.
So the date type is like this is the format of the date type in R.
Yeah. So sort of R will take its format.
Yes.
So it's like we are getting the so like this is the
Yeah,
like
and I think it's not about just the matching. It's we just with using the code, we extracting, we like our read CSV function here are just like getting the date, even if it doesn't know that it's a date. I think it internally knows that it's a date column because of the structure and the like separation internally. Then with the call date, we just like format it. I say this because the three example here, we see like we beginning with the months, then we beginning with the day, then we beginning with the year. So it's three different formatting for each one. And this is how we wanted to present it in R. This is the output that we want. So we formulated a column that really like with the code that we want to be presented in the tuple, so that the resultant tuple here.
Yeah.
Yeah.
Yeah. So what I'm saying, it's like it's not really conforming with what we are specifying here. It's like R is taking its own form, Is it because of the call date function, or is the or the date, the call, is it because of the call date function, which is why it's behaving like this, or the date?
Yeah.
Because I was thinking that here it would have started with the month, the date, and then the year, but it's still giving us this.
Yeah, I think they match, but how like the second and the third are the same because the CSV it doesn't change.
Yeah, the CSV doesn't change, and
So how they are changing the formatting.
Yeah, it's like because I was going through it and then look at the third one. It even makes it more interesting because look, the year we have like 2001. You know,
Yeah.
where is this coming from?
Maybe say something about this. Know that
Yeah,
no
yeah,
matter how you specify the date format, it's always displayed. Yeah, he says something about this in the book, I think.
yeah.
He says it's
Yeah,
ambiguous.
so he's saying that no matter how you specify the date format, it's always displayed the same way once you get into R. But look, that's not the case here because this 2001, you know.
Yeah, it's 2001.
And the CSV file we have it's 2015. So.
Oh yeah. I think it's just okay. So I think I get it. It just
Mhm,
like it's just piping the date from the CSV variable
mhm,
to what we are specifying in the column date function. So
mhm.
the column date function, we just specify the codes in order.
Yeah,
So in the first example, we say, okay, 1 is a month. So and the day is 2 and 15 is a year.
yeah,
So that's what we see. We see it in the result. It's the same, like R just formatted that way.
yeah,
But he understands that we treat the first one as a month, the second one as a day, and the third one is as a year. In the second example, it's just different. We treat the first number as a day, the second
mhm,
number as a month, and the third number as a year. So, but R also just transferred all this into the same format. So it doesn't matter how you format it, but it just take uh, the um, the format match the formatting that we get from the CSV variable to get the numbers. When we get the numbers, when ours gets the numbers, it just display it as we use say to display it here in call date. So here in the second example, what do you expect? We expect that the day is 1, which is the first thing that you see in the CSV variable. You get
yeah,
it? Like if you like move like up a bit, you see the move up a bit, up. I
yeah,
yes. So 1 here is the day.
mhm,
You see it like so in the second example we say that the day is the first one. So he takes the 1 and the second treat it as a month. The third treat it as a year.
yeah,
Yeah, so it's just different format, but it's just like extracting the numbers based on the order that we specify
yeah.
and are just display it
Yeah,
the
yeah.
same way.
So I was saying that the problem is with the third one. How would you explain that? Because
Yeah, the year here
it's given us
again, it's
2001.
yes, it's order is about the order. So you
Mhm,
see the order here, we begin with year. So in the CSV, we passing it to 1. You see, like 0 and 1 pass it to year. So it's
yeah,
just 2001, yes. And 2 is passed as a month, 15 passed as a day.
yeah,
So yeah, that's how we like it's mapping just the format.
yeah. That's a problem because this could be misleading.
Yeah, yes. That's
This
why
could,
you have to be careful when you format the date
yeah, yeah,
with
true,
this
true.
function.
Yeah, yeah. Thanks for that. So it's saying that if we are working with non-English dates, we might need to use this function, and then it will sort of help us with how to do some adjustments. So basically, that's the part when we sort of import the data. Now it's looking at when we are dealing with strings. So when we are working with strings, so we also still have to identify the order in which year, month, and day appears in your dates. Then rearrange like Y, M, and day, where the Y is the year, M is the month, and the day is the date, in the same order. That gives you the name of the loopy date function that will pass your data. For example, if we do like this, we expect it to be year, month, date, and then this one, of course, it will be the month, the day, and the year, and then this will be the day, the month, and then the year. So the YMD function and friend create dates to create a date time r underscore, and then use one or more of like this. So just to add the time, we just modify this YMD, and then if we add the HMS, it adds the hours and the minutes and the seconds. Yeah. We could also force the creation of date time from a date by supplying like a time zone. Like the TZ will set our output to like the universal coordinated time zone, which is also the same as the GMT at 0 degrees latitude. So also we could create dates and times from individual components. Then now here it's going to the flight data set. Instead of a single string, sometimes you will have to you will have the individual components of the date time spread across multiple columns. So like here we have the flight. From the flight, we could select the year, the month, the day, the hours, and the minutes. And then we could clearly see what is happening in January, and that's the hours. So this might not be very informative, just like this. It might not be very informative. We might need to sort of create some date time columns using these functions to make sort of the data more informative. So we can use the make date function for dates, or make date time for the dates and date and times. So we use the mutate function where the departure will get set it like this to make date times. And now looking at this table, we could see it looks more interesting. Now we could see how the flight data, departure time and date behaves. We could see like the hours, the minutes, and then with this, the departure, you could see now it's even much more clear.
Yeah, nice way to define dates. I think
Yeah.
they get like the make date and make date times. It became easy to construct date from individuals columns.
Yeah. And with this, you could easily do some very good visualizations.
Yeah.
So he's like, we could sort of use the modulus arithmetic symbol to pull out the hours and minute component from the data. Once we have created the date time variable, we focus on the variables we will explore in the rest of the chapter. So we could use the modulus by 100 divided by 100, and the the modulus. So sorry, do you know how this symbols are called? Because this is modulus, but how will this, is it divided or?
I think they call the remainder.
Yeah, the remainder. Yeah.
Yeah, it's called the remainder. I think it's a modulus.
Yeah.
So yeah, I know
So
it's a modulus, but
yeah, I think the first one is just if we divide the value we have,
yeah,
and then the second one might be the remainder. I don't know.
it
Because I'm
could,
seeing the division sign here as well.
yeah, it could be like he just didn't um provide the second one, but he said that he want to pull out the hour and the minutes.
Yeah.
So we have the time and we want to pull the hour and minutes from time. So
Yeah.
he did it, or yeah.
Because it's pretty much because pretty much you could see the departure time here looks very good. So it's what he does want to do here. So anyways, with that adjustment to get the 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 hours and the time, we could look at the departure time and the arrival time with this make date time function. Like this, when we use this make date time function with the division by 100, we could see the arrival. Sort of, we could easily see the difference between the departure and the schedule, like the delay, the departure delay, the arrival delay. We could easily see it like this, which is really cool. So these are some of the things we might want to zoom in from this data set. And then we could easily visualize that using the departure time. So here, like the bandwidth is set to the number of like seconds, which is like 86,400 seconds in a day. So that's what we have in the counts. The counts is picking the seconds and then the departure date, like the time. This doesn't seem to be very informative. What do you think?
Yeah,
Yeah,
it
it doesn't seem
should,
to be very.
it has a lot of work to
Yeah, yeah.
be
It's
done for
zooming.
it.
It's like it's compact. A lot of things are compact together, so we have to zoom in more to
Yeah.
make sense of this. Yeah. Like now, if you look at a single day, then it gets more interesting. You could see now it's getting more interesting. So basically, the departure time, I think the mean it's just somewhere between 5 and around 10. You know,
Yeah.
yeah, somewhere around 10. So I think the date the make date time function makes life very easy for us. We could easily zoom in the data and see how it gets more interesting.
Yeah, I
Yeah.
think we will use it very much in every time analysis that you do.
Yeah. From other sources, you may want to switch between a date time and a date. That's the job of as date time, as date. Like if you want to switch, so these functions are pretty much handy, and then they could help you switch. And also when the data, sometimes you will get a date time as numeric offsets from the Unix approach, like this. if the offset is in seconds, use the as date time. If it's in days, use the like as date. Yeah. Yeah, I think that's it. If you want to make any comments before we move to the next section, next section. You with me?
Yeah. Let's move. Yeah.
Yeah.
Good move. That's okay.
So the date time components. So we could also so we could explore. We could use this to explore more the data. So in this section, we'll focus on the accessor function that lets you get and set individual components. The next section will look at how arithmetic work with the date time. So getting components, we could get component from our data using some of these functions from the accessories. We could use the year function, the month, the month, day, like let's say day of the month, the year, day of the year, the day of the week, the hour, the minute, and the second. These are effectively the opposites of the make date function. So these are quite handy, they just make life easier for you. We could also use the label. Oh, we've seen this last week, the label. So when we set it to true, it gives us the generic labels of the months or the days of the week.
As a factors.
Yeah. So we could zoom in to the week and see that more flights depart during the week than on weekend. Like if we zoom in using the week, the weekday, could see, and on Saturday, less flights, which I think makes sense.
Yeah.
We could also look at the average departure delay by minutes within the hour, and we could see an interesting pattern here. It's like the average departure, it's somewhere between like 20 to 30, like the delay.
Yeah, 25 to 20 to 30, I think.
Yeah,
25.
have like the lowest on average.
Yep.
Yeah. And it's like if we look at interestingly, if we look at the scheduled departure time, we don't see such a strong pattern. Because look at how it's still compact, even though it's better than the first visualization we have, but you could see it's still compact, and we are not seeing that information. Look from here, we cannot see.
Yes.
That. Yeah. So
you have to be concise and try to zoom more.
Yeah. Try to zoom in more. Yeah. Try to zoom in more. And then here it's like saying how the data easily prefers to easily rounds up to certain numbers, and like so sort of a data like this, we should be alert if we see like something like this, because a frequency polygon showing the number of flights scheduled to departure each hour, you could see a strong preference for round numbers like 0, 30, generally for numbers
it could be like you could use it like an anomaly detection methodology to to see if something goes wrong, an alert is activated and we're do something. So yeah.
Yeah, so we could also use the rounding. We could an alternative approach to plotting individual components is to round the date to a nearby unit or time. We could use the floor date function, the round date function, and the ceiling. So each of them will takes a vector of dates to adjust, and then the name of the unit rounds down floor, rounds up in ceiling, and round two in round. So yeah. So here the floor, it's going to round down.
Very interesting that R have a function for everything almost.
Yeah, almost, it has some interesting functions.
But I think if they really implemented like the object-oriented design, they will make selling function that's a normal one deal with dates also. So I don't. It may be because like they have multiple pattern or design methodologies other than object-oriented. So yeah.
Yeah, so I think these are just showing us how the round, the ceiling, and the floor functions will usually work. So here is saying that computing the difference between a pair of date times yields a different time. More on this, and so you can convert that to an hours minute object to get a more useful access. So like if we want to compare like different dates and times, we could just convert them to one, like the like an hours minute or seconds object, and like that it will be easier. We have a single useful x-axis. Here is talking about how to modify like components in your data. You could do that to using the year function. We could modify the year to any year we want, the month also to any month we want, the hours also to any hours we want, which is in a sense easy. Or alternatively, you could also use the update function to do these modifications. So I think the update function seems much easier to use.
Yeah.
Yeah.
More intuitive, I think.
Yeah, than using the others. Yeah, I think that's the final part of this chapter. How to use arithmetic with dates, working with date works, including subtraction, addition, and division along the way. You will learn about the three important classes that represent time spans, like which is the duration, which represents the exact number of seconds, the periods, which represent human units like weeks and months, and the intervals, which represents a starting and an end point. So now we look at the duration, which is like the exact number of seconds. In R, when you subtract two dates, you get a different time object. Yeah. Like the date today minus this particular date, we get like a time difference of 15. 15
His
years.
age, yeah, his age.
Yeah.
But in time, in days, yes.
Yeah, age in days, yeah. Yeah, so this helps us with the duration. So we could also as duration, then we can easily convert it to in years. if you use the as duration function, which is like 43 years. Yeah. So and these are some of the convenient constructors that are in the duration function. The d seconds, which converts it to a second, like d minutes also gives us the equivalent in minutes, gives us the equivalent in hours. Yeah. But these are just some constructors that work with the duration function.
Nice.
And then depending on what you're doing, the duration function could be very useful. Yeah. Depending on what you're doing. We could also add and subtract. You can add and multiply like 2 times the years. The years one.
Yeah, you could basically do any like arithmetic
Yeah,
operation.
any arithmetic operation you could do. Yeah, so it's given some caveats that, however, because duration represents exact number of seconds, sometimes you might get unexpected results. Like here, which had the, yeah, so it's giving us on. Yeah, so 1 a.m. plus an extra day. So if we do that, it get like it's look, it's giving us a different time zone.
Yeah.
Yeah. So this it's, I think this is the anomaly he's talking about. Yeah.
Oh.
So one has to be mindful of this.
Yeah, because it may introduce a lot of bugs.
Yeah.
Because any change, but how you like construct the first time zone, like the EST?
Yeah.
I think he changed it based on the time, not on the variables that we specify here.
Sorry, the time zone.
Yeah, the time zone EST. I think they. Yeah, I don't know. But I think it's a bug, so we can't like know how it's been introduced to the code. So
yeah, so I think the main problem is because here, it mentioned about the daylight saving stuff.
yeah.
So it's around this time that the daylight saving happens, and it's not able to deal with that, and that's why it's giving us some crazy results.
Interesting.
Something like that, because why is 1 day after 1 a.m. March 8, like 2 a.m.
Yeah,
March
it's when the
if you look
ST
carefully,
starts. Yeah.
you might also notice that the time zone has changed, because this particular March 8 has 23 hours because of this daylight saving starts.
So it's not a bug. It's like
It's not right.
it's a bug in our end.
Yeah.
Yeah.
So we could also look at periods to solve this problem. Lubricate provides periods. Periods are time spans, but don't have a fixed length in seconds. Yeah, interesting. Instead, they work with human times like days and months. That allows them to work in a more intuitive way. Like if we adjust, you see now it's like if we add one day to it, it goes the following day, but the time zone changes from EST to like EDT, but which is mainly because of the daylight saving stuff. So we could, it also has some interesting functions we could use. So we could use the hours function, the days, could give us the day, the hour, the minute, and also the second, and the months. We could also use it to do any sort of arithmetic operation. So it is saying that compared to duration, periods are more reliable. Sort of they are able to handle like daylight savings more appropriately than durations. Yeah, I think this is something similar to what we have seen previously. It's just trying to show us how to deal with the daylight saving stuff. And the third component is the intervals. So what does like D years 1 divided by D days 365 returns? It's not quite 1 because the years function is defined as the number of seconds per average years, which is like 365.25 days. So like when we use this, we have 365.25 days. So if we, so basically it is like the main reason why we want to use the interval, it's both the duration and the period have some limitations, especially when we want to do some like divisions. They have some limitations because they will give us inaccurate, imprecise, like this doesn't make any sense. You know, 20.25 days doesn't exist. So if you want a more accurate measurement, you will have to use an interval. An interval is a pair of starting and ending date times, or you can think of it as a duration with a starting point, something like this.
Yeah, I think it's not about the arithmetic division. It's about the unit. I think that the unit here is days, and days doesn't like we don't have like a factorials on dates. So the dates have to be a real number. That's why the function itself doesn't made for this, like to make them a real number. I think they designed it to just do it for as a number, just a number, a floating number. That's why we see the 25 here.
Sorry, maybe you could.
Yeah, it's. I think each function returns a floating, a double, something like that.
Yeah.
So that's why we need interval here, and because we are dealing with days, and days is just real numbers. It couldn't be like like if like a factorial or like 0.5, 0.25 or something like that. So that's why we need interval here.
Yeah. So basically saying that like the main thing is like an interval will gives us has a starting point and an end point, which will make it easy for us to in this case, we could easily divide by the, we could, you could then divide by days to find out how many days fits a year, because we have been very precise here by using the interval function. So we started from like 2023 on the 1st of January to like 2024 1st of January, which is quite precise. And if we do division with that, with days, we have exactly 365. Yeah. So like 2024 has a leap year. That's why we are having this 366. So basically, I think the interval makes it easy because it generally the only difference it has with the duration and the period, it specifies a given interval, which makes our calculations a bit more precise and more accurate, especially when we are doing like divisions.
Yeah.
Yeah. So now it looks at time zone, which is the time zones are enormously complicated topic because of their interaction with geopolitical entities. So, but like unfortunately, we don't need to dig into all the details, as they are not all important for data analysis, but there are a few challenges ahead. The challenge is that every day every day names of time zones tend to be ambiguous. For example, if you are American, you are probably familiar with EST or Eastern Standard Time. However, both Australian and Canadian also have the EST. To avoid confusion, R uses international standard INA time zone. This uses a consistent scheme like the area and the location, typically in the form continent, city, or ocean city examples. Yeah. So basically, it's motivating why we have to look at time zones.
Yeah.
Yeah. So you could find out what are things your current time zone is with like the system time zone, which is a quite cool function. Let me do that and see whether it gets my time zone right. Just a little digression.
And I think it's explained why we see the default one in others, the UTC here.
Yeah, you get my time zone right. Oh, this function is interesting. Yeah, so the default is UTC like. Yeah.
And I think if you could use it like to compare and to modify other columns if you have in that your data sets to match your time zone.
Sorry, no, I didn't get you.
Yeah, I said that if you could use it to modify your columns to match your time zone.
Yeah, sure. Yeah, so and if R doesn't know your time zone, it gives you an INI, which I think that might not be the case. In any case, I think R should know your time zone. Or maybe unless your location is like maybe hidden or something like this.
Yeah, it could be like other time zones that they don't recognize from the system. Something like some limitation.
Yeah, of course. So this is just a complete. You could see a complete list of time zones by using this length Olson names, and then this will give us all the time zone
list of all. Yeah.
So we have like 597, almost 600 time zones. Wow, that's a lot, you know.
Yeah.
That's a lot. Right, so we could do a lot of other adjustments with the time zones based on what we have already studied. These functions, we have already seen these functions. We can verify that they are the same time using the subtraction. Like if a difference is time difference of 0 seconds, shows that basically they are the same. So unless otherwise stated, it always uses the coordinated universal time as the default time zone, which is roughly the Greenwich mean time. Yeah, I think that's it. If you have anything else to add.
No, thank you for presenting, and it was very
Yeah,
interesting.
but it was something we did together, so I was like, yeah, thank you.
Yeah, but it's interesting that we discuss the chapter, not just it just doesn't it give more when you discuss it with someone, not just go through it yourself. So
yeah, of course, you know, because I was making some mistakes, and you know, like you made some corrections to the way I was understanding the whole thing. Yeah, I think it's good, you know, when you discuss with someone, you learn from a lot from them. Yeah,
that's why we here
basically that's it. Yeah, that's it. Yeah.
So yeah, you can we can end it here, and thanks thanks for your presentation. And I think let's see what is the end chapter, the other one. We have like missing values, chapter 19. Shams will present the next one, and after it I will present joins. So thanks for your participation, and have a good day.
Yeah, thank you. I hope to see you in other book clubs.
Yeah, me too.
Yeah, thank you.
Yeah, see you later. Bye.
Bye.